right, welcome everybody. This is B Crow with X Producer B. We're coming here today with an exciting video, actually a video series that I'm starting, one that's been highly requested. And instead of doing a script release or something about controller, we're actually going to start a series today on MIDI scripting with controller devices. So if you're interested in learning on how to do scripting with various MIDI devices to make them work with various different types of software, this series is going to be for you. We're going to start with some very basic things, and then towards the end of the series, we'll dive into some specifics of programs such as Ableton Live, Studio One, and then we'll even go through FL Studio. But once you get the basics down, I guarantee you'll be able to take this and go forward. So stay tuned with the whole video series as we go forward. But today, we're just going to start off with the basics about MIDI. So let's go ahead and get into it right now. All right, so I've got the screen pulled up here, and I'm going to rearrange some things on my desktop so you can see what we're talking about. In order for us to really gain an understanding of what's happening here, we really have to understand MIDI as it concerns music instrument devices. And that's what the acronym stands for. MIDI stands for Music Instrument Digital Interface. And so what that means is that every time you interact with the MIDI device, it sends data from the device to another device. It could be another instrument. It could be another. It could be a computer or a host device, or like a controller type of device. It could be a sound module. It couldn't be musical at all. Sometimes people will use MIDI to interface between devices that aren't even musical, such as maybe some lighting devices can use MIDI, or some other pieces of software can use MIDI. But essentially, all that MIDI is a way for you to interface digitally from some device to your computer. So you don't have to overthink it. They crafted a way to do that. The specification was made, I think, back in the 80s. And so it is kind of outdated in its implementation, but it is widely adopted. So if you know how it works, you can really go very far with making some things work. So let me tell you what I'm talking about here. Right below me, I've got the controller. This is the MPC Studio MK2, the Mark II, the newest one that they have come out with. And I've got it plugged into my computer up here. And then on the computer, you'll see that I have a MIDI monitor that is plugged in. And essentially what this does, it just allows me to see the data that is coming back and forth in between this device and the host computer. And so as you'll note, if I start turning the knob here, or I start pressing pads, anything to that nature, if I start pressing button, if I start moving the touch strip, you'll see the data coming back and forth. Okay. And so this is the information that is coming into the computer. And it looks like gibberish, but I guarantee you by the end of this video, you'll be able to recognize what actually is going on, because there is a standard and it is already defined. This is the MIDI out monitor right now. I'm not sending any data out. However, if I were, you would see that data coming out from the computer. Okay. And on the left-hand side, I have what is a breakdown of the MIDI message. So essentially, let me see if I can break it up here and show you. MIDI, when a controller sends information, it sends it in a series of bytes. And in particular, it sends 3 bytes. The first one is a status byte. All right. The second one is going to be an ID byte. And the third one is going to be some sort of a value byte. Okay. And a byte is just simply 8 bits. Don't get, too bogged down with what that is. 8 bits, meaning 1 byte is 8 bits. So 1 bit is 01. So we say 1, 2, 3, 4, 5, 6, 7, 8. That would be 1 byte. All right. So that's the information that it sends over. That's binary. I don't want to teach a computer science class, but essentially binary is just a way to represent numbers in a binary system, meaning 1 or 0. Okay. So the way that it works is that you actually start, of course, from this position, the right, go down to the left. And if this first bit is 1, then that's 1. Okay. If the second bit is 1, then that's a 2. So this binary would be 2 plus 1, that is 3. If the third bit is a 1, that would be 4. So 4 plus 2 plus 1, that would be 5. If I change this first one to 0, that would be 4 plus 2 plus 0, which is 6. I mean, 4 plus 2 plus 1 is 7. Sorry, and this would be 6. So that's what it is. When you say a byte, you're talking about 8, 3, 4, 5, 6, 7, 8 of those bits. However, MIDI in its implementation is special because it actually only uses 7 bits of that 1 byte. Okay, and so that's the data that it sends. The first byte is called a status byte, and it tells you 2 pieces of information. It tells you what MIDI channel, and it tells you what type of message it is. That's why it's called a status byte. So what the type of message is and what channel it is. All right. The second is the ID byte, which basically identifies something on the controller, like we'll say a controller CC number, or it could be a note. What note are we having? And there's some other identifications that can be sent over, but really these are the these are the 2 common most. This is how the devices know what MIDI notes you played, because when you press something on this controller, it sends in that second piece of information. It tells you what note it was, or in the case of controllers, it'll tell you what controller it was. And the value, of course, is what it is. It'll tell you the value for your that you're sending to that controller or that to note. So if I press it hard, it'll give me a value of the highest value is 127. And if I press it all or note off, will give you a value of 0. So one thing to note is that all of these values go from 0 to 127. So this is just 0 to 127. Same thing up here, except these 2 bytes are different, and we'll talk about that in a second. So the largest number you can send in a 1 byte over MIDI is 127, starting with 0. And so technically it's 128, but in programming, computer science, 0 is an actual number. So we count that. And so this is the breakdown of what MIDI is. Now, to the right of the screen, you'll see I have this MIDI monitor pulled up, and it has 3 bytes here, but it's not in the format that you would think. It's like 89 and 52 and 00. Well, what's that all about? That is what's called hexadecimal. And hexadecimal, it really is the most common form to interpret MIDI data, because you can interpret large numbers by looking at just a couple of numbers. I'll show you, give you an example. If we go back to the screen here, what a hexadecimal is, it is 16 digits represented in 1 character. So we're talking about 0 through 9 and then A through F. That would be in hexadecimal. If you count that, if you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, and then A, B, C, D, E, F, that is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so hexadecimal is actually base 16, which means that the first character represents 16. So if I have F right here, it's 16. All right. Well, so if I see this number, it's 16, 0 in the second position. Now this requires some math to get it right, but just suffice it to say that this is how MIDI data is represented. Okay, it's done in hexadecimal because you wouldn't want to look at it in a format that was just like that. Okay, you want to look at it, you know what that is, but F0 is widely recognized. Okay, and once we get into the code, I'll show you very easy ways to go back and forth in between hexadecimal and decimal and even binary formats. Okay, so the way that the status byte is arranged is that with this format, the first one of this will tell you what type of message it is. All right. The second character in this tells you what channel it's on. Okay. This is why, by the way, MIDI has 16 channels, is because they only have 16 numbers in that first byte to represent channels. So MIDI is limited to the 16 channels, with the first part of that byte showing you what type of message that it is. And of course, there can only be 16 types of messages, but there's really only a few common messages. So I've got a chart up here. This is called the MIDI status byte chart. Okay. And so you'll notice that it has a status byte up here. So if you see a MIDI message that comes in with an 8 at the beginning, it is a note off message. And if you see MIDI comes in with a 9 at the beginning, it is a note on. Same thing with A. We have a polyphonic. A note type of B is a control message. And then a note type of C is a program change. And D is aftertouch, and E is pitch bend. Okay. Now the second part is the channel. So if I get a note message, if I get a message that comes in that starts with let's say 0x is normally a good way to start hex. 0x8, it's a note message. 0 means channel 1, because remember in MIDI 0 is an actual number. Okay. So when we're talking about binary or hexadecimal, this 0 is actually 1. If I see a message that comes in with 8.1, I'm on channel 2. If it comes in with 8, we'll say 9, that's on channel 10. If I come in with 8F, that's actually on channel 16. Okay. And so that's how you can get the different status bytes with the MIDI message. If I see a message that comes in that starts with B and maybe 0, I know that that's a controller change that's coming in on channel number 1. Okay. And remember, there are 3 bytes. So let's say the next portion of that byte comes in. It says this 0x01. Well, that means this is let's walk through it. That means we have a controller message coming in on channel 0. All right. And it is for controller 1, or excuse me, controller number 2. Because remember, 0, 0 is also a number. That would be controller number 1. This would be controller 2. Okay. And if I saw this 0x7, 7F, that would mean I'm sending a message in for control on channel 1, control number 2, and I'm sending a value of 127. All right. So that is how MIDI devices communicate. Those are the majority of the messages that are sent back and forth. There's only one, there's a couple of special cases. I'm not going to go through an exhaustive overview or explanation of the MIDI specification and talking about real-time messages and all that. But probably the next most common type of message you'll deal with is what's called a system exclusive message, which all of those start with 0xF0. Okay. And they all end with 0x7, 7F. And what these are vendor specific messages that are used to send large amounts of data over MIDI to the device. And this is very useful if you want to send some data that's not necessarily just a MIDI message. Okay. What if I want to send a text? Let's say I have a controller and my controller has a screen on it and I want to put something on the screen. Well, you can't send that over just regular MIDI notes, at least not easily. You would want to send that over system exclusive. Let's say I want to be able to update the firmware or change settings on the device. That would be sent over system exclusive. In the case of this particular pad, this MPC Studio 2, the way that they actually control the screen and control the pad colors and control the device mode is through system exclusive messages. And if you put in a MIDI sniffer, do a USB packet capture, you can see a lot of that information coming back and forth over the device. So that's a breakdown of the MIDI specification as it pertains to how devices communicate normally. If you know those two things about regular MIDI messages and system exclusive messages, you'll be able to program the majority of your devices and be able to understand what's going on. So with that now out of the way, I want to go into my MIDI monitor here, and I hope I'm going to try to blow this up. Let me see if I can make it maybe a little larger. Preferences. No, it doesn't let me blow it. Oh, here, font size. Let's go large font size. There we go. Maybe that's a little bit better. Hopefully you can see it. This program is called Pocket Midi, by the way. And it is a pretty good MIDI monitor. There's another one on here that I have that's a little bit better because it does a better job of snooping outgoing messages. But here's the MIDI that's coming in. Now, notice I'm going to go to the overhead view on the controller. And so I've got the controller here. If I can light it up so you can see what's happening. All right. I've got this knob here. Now, let's turn this knob and let's see if we can see what message it's sending. Okay. So now the message came in. I just turned it once. It's an encoder. All right. Now over here, it kind of tells you, it decodes it for you, but let's look at this. Let's look at what it's sent. B represents a controller change. 0 represents channel 1. Okay. This is the ID 64 actually in hexadecimal equals 100 in regular base 10 numbers. All right. And so, and this is also set a level of 1. When I turned it clockwise, it sent 1. Notice if I turn it counterclockwise, it sends a different message. It's still a controller message. It's still on channel 1, and it's still ID hexadecimal 64 or 100, but it sent 127. Okay. And that's how the encoders, most endless encoders, that's how they work. If you turn them one direction, they'll send one number. Turn them another direction, they'll send another number. There are some that will send speed, and they'll encode the speed in there. And I think we'll get to that a little bit later on because the MPC Studio Black does that with its encoders. Once it's in private mode, it sends the speed so you can turn it faster, and it will tell you pretty much how fast you're turning it over MIDI messages. And it's pretty cool how they do it. It does like 2's complement and some other things. And so that's how it does. So let's look at another thing. So let's look at this. Let's go back to the overhead screen. Let's look at the button now. I'm going to press the play start button and look it on the screen. So let's break this down. It sent I'm pressing it, which means I sent a note on. All right. That's a 9 is a note on channel 0, hexadecimal 53, which is actually 83. All right. And then note on sends a value of 127. When I release it, it sends a note off channel 1, still hexadecimal 53, which is 83. And then it sends a 0 in the value area for note off. Okay. And I can press it on and off, on, off, on, off, on, off. All right. So now you see how this sends, and controller messages and note messages are probably the most common type of messages that you're going to interact with over the whole time. So using that information, what we can do is we can actually go through and see on this pad, we can see what each pad note is sending. So this pad 1 is sending a note on at value hexadecimal 27, 37, 36, all right, 42. These are not hexadecimal, these are actual numbers. 82, all right, 40. And so the pads are sending kind of a random pattern, which I notice Akai does with its pad controllers. These guys send what is to me random numbers. Okay. Now notice if I hold the pad, it's actually sending aftertouch. So as I press down, notice it sends aftertouch messages too, all the way up to 127. So it even senses the pressure and is sending that data as I press hard or I press soft. So it sends a note on, then it sends an aftertouch messages. And if you have some keyboards out there, some of you might be familiar with the aftertouch. Well, that's how they're doing it. Okay. The MIDI already has that built into it where you can send pressurized messages encoded between values of 0 and 127. All right. Another one I want to talk about is this touch strip over here. It's like a slider. Okay. So if you have like a slider on your controller and you turn it, it'll send values between 0 and between 127. Okay. All right. So that's how MIDI works overall. And using that information, what you can do now is you can actually capture the information that is going to or from your computer to figure out how your devices are working, even if the manufacturer doesn't publish specifications for the device. there's some caveat to system exclusive because there is no open standard for system exclusive. Okay. And so what I did when I was programming these controller scripts, I opened up this program like this. And I also had, I'm a network engineer by certification through some years ago. So I know how to use packet captures, and I opened up a packet capture between my devices to capture the system exclusive and reverse engineer those to figure out what messages it was sending to correspond with the events that were happening inside of the program. And using that information, I was able to figure out this device here, that how they were sending the pad colors, how they were even controlling the screen. Okay. Because I was able to see that binary data, break it down and decode it to figure out how the devices work. And using that information, you can make these controllers work with whatever programs that allow DAWs, that allow scripting functionality into it. So let's go now into the programming side of it. I'm back into, this is the Visual Code, Visual Studio Code, by the way. It's my preferred editor of choice. Don't come for me. It just is what it is. I want to preface this by saying this will not be an exhaustive class or tutorial series on Python or JavaScript or whatever language you're scripting in. Most of the popular ones are Python and JavaScript. I think there's some Lua out there and maybe even some Java. But most popular, what I've seen with these devices, most people are using Python, Lua, or JavaScript because those are very, very embeddable scripting languages, and most popular then being Python, with Ableton Live uses Python under the hood, and then FL Studio also uses Python under the hood. So I'm not going to be teaching a Python class. It is expected if you're here, you're probably at least familiar with just a little bit, though Python is very approachable. Okay, so you're expected to have a little bit of Python knowledge. All right. And so right here, I have a Python application, if you will, started. And I have just a few requirements that help me to work with MIDI devices. The first one is called Mido, which is a Python MIDI library. Excuse me. And then it has a requirement of Python RT MIDI if you're on a Mac, because RT MIDI is a C implementation of a MIDI and allows you to interact with the MIDI devices on your computer. I'm not going to go into C or C++, though I do have applications I've written, and I've written controller scripts or controller programs in C++. We're not going to go there today. Just suffice it to say, these are the two requirements, and they have websites out there and documentation to help you to install them and walk you through the process of installing some of their requirements. And so I have that here, and I've already chosen an output. I've wrote a couple of functions that allow me to choose an output and allow me to choose an input. Okay, so what we're going to do, we're just going to play around with this MIDI controller here that I have. Okay, and so I'll open up a terminal, and hopefully you can see this at the bottom of the screen. I don't know. Maybe I'll put this on the overhead. I'll just run this. I'm already in my virtual environment. Python 3 main.py. There we go. So it's going to give me a choice to choose my output index port. So I'm just going to choose port 4 and then port 4. Okay, now it's open MPC Studio. And notice I have it set up to where every time I turn this device, what it will do is that it will print out the information. So right now it's telling you I'm on channel 0, the ID is 100, the same information that Pocket MIDI just did. So essentially I just made a MIDI monitor for the input of this controller device. All right. If I press various buttons around here, I'm just kind of going hand pressing stuff so you can see in Python that it works. Okay. So let's look at sending MIDI message, because, okay, we can see what's going on, but what if we want to send something to a device? All right. Okay. And for this controller, I figured out that through observing the communication that was coming from the MPC Studio software, the MPC software, I could figure out how these particular buttons were lighting up. And so what I'm going to do is I'm going to write just an if statement that if the message is a note on, what we're going to do is we're going to print the MIDI message, and we're going to print the ID of the note. Okay, this is a class that I made up here called Midi Message, and it allows me to print various types of that message. So we'll save that, close this out, and we'll rerun it. Choose 4, and let's see. All right, so it's showing me the ID. Why do I want the ID? Because through observation, I found out that to control the LEDs for these buttons, it sends controller messages that correspond to the ID of the message. So in essence, what I can do is what I can say is when this message comes in, I want to, on the out port, I want to send a message. And the message that I want to send is I want to send a controller message. So 0xb0. And I want to send it on the message ID. And if the message, excuse me, I'm not good at talking and typing at the same time. MIDI message dot, let's do if the message dot type equals, let's say note on, I want to send one value back to it. So for note on, I'll send a value of, let's go, I don't know, 3. All right, because we got from 127. All right, you'll see my AI helping me out. If it's a note off, I want to send 0. Okay, so let's see if we can get this to work. I'm doing this live, by the way. There's nothing. If I make a mistake, you're seeing it. All right. Tuple has no attribute bytes. Oh, I have to create a message. New message. There we go. Okay. I have to send that. I wish I could just send a tuple like that, but I probably have a function up there that could do that and just extract that. All right. So here we go. Message.channel, message.id velocity. I'll do the same thing up here. New message. We're going to send a note on the message channel. Okay. We're going to send it on the message ID. We're going to send not the velocity. We're going to send just, we'll go 3 here. I think 3 is a good one. Let's see if we can make that work. All right. So let's walk through what's happening here. First thing we're going to do, we have what this is doing. This is listening for every message that's coming in on the import. And we're going to have some conditional statements on the type of message. So if the message type is a control change, which by the way is something that Mido provides for us, you could check the status byte here and that would be okay. All right. And we're going to do some things for a control change. All right. But if it's a note on or off, basically meaning it's a note message, we're going to make a MIDI message and we're going to print this MIDI message out. And then if it's a note on, we're actually going to send a message right back out. And if it's a note off, we're going to send a message. And if it's a note on, we're going to send a velocity of 3. Okay. And if it's a note off, we're going to send the velocity of 0. The next thing we've got to do is change this message type to not note on. I want to send control changes. All right. So what are we doing? We're receiving a note message, but we're sending a control change. All right. So let's see what happens here. 4. All right. Uh-oh. Oh yeah. ID. This is Mido type of stuff. Don't worry about it. I'm making mistakes in real time. All right. Let's start again. 4. What type of, here, let's see. It says I don't have control. That's what it is. Okay. So this is control. All right. This is control. Welcome to programming, guys. If you thought it was anything different. It's reading a bunch of documentation and trial and error. Unless you know it. All right. Still has no attribute velocity. Why would they do this? Same thing. Same thing, man. value. All right, last time. Fourth or fifth time's a charm. Let's see. Okay, we got it. All right, there we go. So now let me show you what's happening here on the overhead. So remember, I'm sending in a note value, but I'm sending out a control change on that same value. So look at the notes. They light up now. So basically what I've shown you is that I can control this device and what buttons light up by the message ID that I send out. Okay. Now this came through a process of discovery. All right. If you look on the screen, you can see the ID. So with that information, I'm even all the way over here. When I press the button, it lights up. Okay. Now, when it doesn't work for the pads the same way, because the pads work in a very different manner, and I'll talk about that in another lesson. But what this shows you is that using this type of Python script, we can actually control what the device does. We can control how it lights up, and we can control how it interacts with pieces of software. And Ableton Live and FL Studio uses the same information. Okay. All right. So we're going to pause the series right there. What this has been is just a very basic introduction to MIDI, the specification, and also to the MIDI message types. And this has also been an introduction to MIDI with Python. Again, the goal of this is not to give you a tutorial on how to program in Python or how to code in Python. What it is just to introduce you to how MIDI devices work overall. So whether you're coding in Python or JavaScript or doesn't matter what language, Go, C, whatever language that has a capability to code in MIDI, the specification is the same. And once you figure out how the device works and how to control the device and its settings through MIDI, you now have the tools to be able to craft some powerful scripts of your own. So hopefully this helps you. In the next one, we'll dive into system exclusive messages, and I'll show you on this pad how I can light up the pad with different colors. And so stay tuned for the next video coming out very soon. Hope you guys enjoy. Until next time, deuces.